Okay, so our last objective for this section is to talk about the mass and the centroid, and it's pretty similar to the work we have done for two variables. So just recall that if you have a continuous density function, so let's call it the continuous density of rho x comma y comma z, then the mass function is given by an integration. We did it for two variables. This time you'll do it for three variable x comma y comma z, and we will say we are integrating with respect to the volume over the region of integration. Then to talk about the centroid, we need three special things. We call them mxy, mxz, and myz. The first one is the same region of integration. Just have you multiply z squared with the rho function and integrate with respect to the volume. Mxz, you multiply y squared with the rho function and integrate, I'm so sorry, these are z and y, I'm talking about the moment of inertia. So you multiply z with the rho function, and this one you multiply y with the rho function and integrate with respect to the volume. And the final one is you integrate over the same region, you multiply x with the rho function, x, y, z, and you do the integration with respect to v. And that is going to give you the coordinates of the centroid. So the centroid in this situation will be x bar, the x coordinate, which is myz, the one that is missing the x term, over the mass. The y coordinate is mxz over the mass, and the z coordinate is mxy over the mass. So as you can recall, we can do the similar type of work for finding the moment of inertias. And for finding the moment of inertias, what you have to do, you have to multiply by z squared plus x squared for the first one. The second one, z squared for the first one. The second one, you are going to multiply y squared. And the third one, you're going to multiply x squared. And similarly, you can find the coordinates for the moment of inertia, the x double bar, y double bar, and z double bar. But we for three variables, we will not do that work. We'll simply go ahead and talk about a problem where we're going to find the mass and we're going to talk about the location of the centroid. So find the mass and indicate the coordinates of the center of mass of the solid region Q of density rho bounded by the graphs of the equation Q equal to 3x plus 3y plus 9z equal to 27, x equal to 0, y equal to 0, and z equal to 0. X equal to 0 is the yz plane. Y equal to 0 is the xz plane, and z equal to 0 is the xy plane. Whereas 3x plus 3y plus 9z, if you set y and z equal to 0, you get 3x equal to 27, so x equal to 3. If you set x and z equal to 0, you get 3y equal to, x equal to 9 in the last one. And if you set x and z equal to 0, then 3y is 27, so y is equal to 9. And put in x and y equal to 0, you get 9z equal to 27, so z is equal to 3. So the intercepts are 0, in fact I start with the x-intercept, so that is 9, 0, 0. Y-intercept is similarly 0, 9, 0. And z-intercept is 0, 0, 3. So that's your plane, which is going to depict the volume for which the mass is going to be found. So I'm trying to find the mass of this tetrahedron, which has the vertex at the point 0, 0, 3, 9, 0, 0, 0, 9, 0, and 0, 0, 0. So that's my setup. So now I'm going to understand this volume in terms of the integration limits. So let's find the integration limits for z. So clearly we know that since x equal to 0, y equal to 0, and z equal to 0 sets you in the first octant, all the integration will start at 0 for the limits. So z starts at 0. how far it can go. So write down your plan, 3x plus 3y plus 9z equal to 27. Set the z by itself and you get 27 minus 3x minus 3y all over 9. So the limits are 0 less equal to z less equal to 1 over 9 times 27 minus 3x minus 3y. Now we look at y. So since I have done z already, we're going to set z equal to 0 and we will get 3x plus 3y equal to 27 at z equal to 0. Solve for y. So y is 27 minus 3x over 3, which is 9 minus x. So the limits are 0 less equal to y less equal to 9 minus x. Finally, for x, you will set y equal to 0 as well as z equal to 0. So you get 3x equal to 27. So x is equal to 9. So the limits are 0 less equal to x less equal to 9. Now it is time to set up my mass integration. So m is integration 0 to 9, 0 to 9 minus x, 0 to 1 over 9, 27 minus 3x minus 3y. The density function is ky dz dy dx. When I'm doing this integration, I'm just doing a polynomial integration, but we have to be a little tricky in order to save some of the energy and work. So 9 minus x, I'm going to do the integration. So k can be taken out and integration of dz is just z within the limits of 0. 1 over 9, 27 minus 3x minus 3y dy dx. So let's put this limit. Again, 1 over 9 is a constant. Take it outside. You get 0 to 9. Integration 0 to 9 minus x. And see, you will get y times 27 minus 3x times y minus 3y squared dy. And this is exactly where we will be a little careful and see this small trick. Since both of these terms has y in the antiderivative, we will now take 3 and y as common. What do I mean by that? I'm going to write it as 3y times 9 minus x minus 3y squared dy dx. And then I start doing the antiderivative with respect to. Okay, so let us do the integration now. So what I will do, I will take this 3 outside and write it as k over 9 times 3 integration 0 to 9, and then I will call it integration 0 to 9 minus x, y times 9 minus x minus y squared, and that is the integrand, which we will integrate with respect to y first. So now we can take the antiderivative. Call it k over 3. Integration 0 to 9, and you get y squared over 2, 9 minus x minus, that should be y squared. After antiderivative, it should be y cubed. So I get y to the power 3 over 3. And don't forget, I'm going to put the limits in as 0 to 9 minus x, and then integrate with respect to x. So I get k over 3, integration 0 to 9. If you put y equal to 9 minus x, you are supposed to get 9 minus x squared times 9 minus x, can call it 9 minus x whole to the power 3 over 2 minus 9 minus x whole to the power 3 over 3. So I need a common denominator now. And the common denominator clearly is going to be 6. So I'm going to multiply top and bottom of this thing by 3 and top and bottom by this thing by 2. So I will get k over 18. I bring this 6 from the denominator out as well. Integration 0 to 9. 3 minus 2 is 1. So this is just 9 minus x whole to the power 3 dx, which is a very simple antiderivative. Just use the power rule. So you get k over 18 times 9 minus x whole to the power 4 over negative 4. So I go ahead and say that this is negative k over 72, and then I will think about the limits, which are 0 to 9. And see, if you put 9, you get a 0, no contribution. If you put 0, you get 9 to the power 4. So what I get k times 9 to the power 3 over 72. So this is 9 to the power 3k over 8. That's 729k over 8. And that's the mass. That's the required mass of the tetrahedron. Don't forget, I'm also interested to find out the y component of the centroid. This is what I'm going to find out now. The y component of the centroid. So what I do, I go ahead and do the integration one more time. The good thing is that the limits are worked out. So I first find mxz, and if you remember, the formula tells you, you will do the integration from 0 to 9, 0 to 9 minus x, 0 to 1/9, 27 minus 3x minus 3y. You will multiply y with the density function and integrate with respect to z, y, and x. So again, as usual, you will take this k out, integration 0 to 9, integration 0 to 9 minus x, and I will go ahead and do the integration with respect to z. First, you look at that this becomes y squared, and z, and the limits are 0 to 1/9, 27 minus 3x minus 3y. Then dy dx, and as usual, when I put z equal to 1/9 times 27 minus 3x minus 3y, I can take this 1/9 out and get integration 0 to 9, integration 0 to 9 minus x, y squared times 27 minus 3x minus 3y. What I do now, when I look at these terms, I factor out 3 from these terms and see what I get. So I will get that 3 outside, and that will be k over 3, integration 0 to 9, integration 0 to 9 minus x squared, and I will get y squared times 9 minus x. Remember, I have taken out 3, and I will get minus y cubed because the 3 is already out. dy dx, and then we start the entire derivative with respect to y. So I get k over 3, antiderivative 0 to 9, as I promised, we will do the antiderivative with respect to y now. So we get y to the power 3 over 3 times 9 minus x minus y to the power 4 over 4. And don't forget, your limits this time are 0 to 9 minus x. So 9 minus x. And now we are going to put in the limits for y, and we will get k over 3, integration 0 to 9, 9 minus x whole to the power 4 over 3 minus 9 minus x whole to the power 4 over 4. Again, you are looking forward to find the common denominator of this thing, which is clearly going to be a 12. So I will write it as k over 36 outside, integration 0 to 9. Inside, you will get 4 times 9 minus x to the power 4. How come? Remember, to find the common denominator, you multiply 4 on top and bottom and 3 on top and bottom. So I get minus 3 times 9 minus x whole to the power 4. And then I do dx. So you get k over 36, integration 0 to 9, 9 minus x to the power 4, as simple as that. And I do the antiderivative, so I get k over 36 times 9 minus x whole to the power 5 all over 5. Limits are 0 to 9. So we get k over 36, and I recall that I'm going to put in x equal to 9. And if I do so, if I put x equal to 9 in my expression, I get 0. If I put x equal to that should be a negative 5, I'm so sorry. And then if I put x equal to 0, I get 9 to the power 5. So this is minus 9 to the power 5 over 5. So that requires a little more simplification. And since I had a minus on the 5, these two minus will make each other positive. And I will get k over 4 times 9, that's your 36, times 9 times 9 to the power 4 over 5. So what I get? I get 9 to the power 4k over 20. And that's mxz. So when I'm trying to find out y bar, which I know is mxz over your mass, I will get 9 to the power 4k over 20 all over 9 to the power 3k over 8. That was the term for the mass. So that becomes 9 to the power 4k over 20 times 8 over 9 to the power 3k. So when I simplify, I get 9 times 8 over 20, which is 72 over 20, divide both top and bottom by 4, and you get 18 over 5 as the y coordinate of the centroid. And that answers my question.